Hello and welcome to Simple PD's presentation on Excel macros, learning VBA by. I am Sam Hansen, and just a little bit about me before we get started. I'm a professional data analyst with over 8 years of experience under my belt in fields including everything you see listed in front of you. Because of this, I spend a lot of time working with Excel to basically organize, clean, sort, and interpret data to find trends and key figures for different clients. And I've, over the last 8 years, picked up a lot of information on how to more efficiently or quickly do these different jobs that I need to do on a day-to-day basis in Excel. And now I'm going to try and pass some of that information along to you. And we're going to start today by explaining what exactly VBA is and how it can help you. So the first question to ask and answer is, what is VBA? And that is an abbreviation that stands for Visual Basic for Applications. This is a programming language used by Microsoft programs. And while the words programming language can sound kind of intimidating, if you've ever done any kind of work in Excel, then I guarantee you Visual Basic is nothing you haven't uh, in some way, shape, or form dealt with, because at the end of the day, it's basically like coding in any Excel formulas just with a slight different type of punctuation at times. So because of that, you don't need to know any programming languages in order to use this. You don't need experience with Java or C++ or HTML or anything like that. Just knowing how to use Excel and the things I'm going to teach you today is going to be all you need to know in order to take advantage of VBA. And like I said, the main reasons to use macros is because they let you save time and create custom functions that do exactly what you need to do. And this can help you, instead of having to type out all these long, complex formulas, basically cut down on all of that effort to make things quicker and easier and hopefully less confusing. And another nice thing about VBA is that it works across multiple sheets and workbooks simultaneously. So if you can do this one time in one place, you can make it apply just about anywhere in any of your Excel workbooks. And that saves you time more and more as you move forward. So the first thing we got to learn is how we can enable VBA in Excel, because it's not just something you can automatically start working with. There is a hidden tab called the Developer tab that lets you access all of the different functions and options that come along with the Visual Basic suite. And to enable that, the first thing we need to do is right-click anywhere on the Excel ribbon and click Customize the ribbon. From there, we will go to the right side and click Main Tabs, check the Developer checkbox, click OK, and there it is for you. And now that I've kind of walked you through the steps verbally, let's see it in action. So here we are in Excel, and you do not see a Developer tab anywhere in sight. But if we right-click, we see Customize the ribbons. And we move over here to the Main Tab section, and there's only one box unchecked, and it says Developer. So check that box, click OK, and now up at the top right after the View tab, you see Developer. And you come in here, and now you see everything that we need to work with Visual Basic. So you may have heard me mention a couple of times uh, what I like to refer to as a macro, what everybody in Excel community uses Visual Basic calls macros. And basically the best way to think about this is a pre-recorded formula or list of steps to be performed in Excel, instead of being a micro action that only takes place in this one cell when you execute it. A macro can be a large scope or a large number of steps all executed at the same time. And a nice thing about this is if you create it and you aren't happy with it and you want to maybe make some changes later on, instead of having to start from scratch, you can basically go in and edit all of the different steps that are contained within this macro to tweak it and make it work better for what you need. So enough talking about it, let's get started. Let's make our first macro. So when it comes to how to make a macro, Excel has this very wonderful feature called a macro recorder, which basically does all of the coding for you for any kind of Visual Basic applications macro you want to make. Now this isn't required. If you want to write it by hand, you definitely can. But if you wanted to do something very quick and straightforward, you could just click the macro recorder button, and then every step you took from that point forward until you clicked stop recording would be recorded into a macro for you. So now we're going to come into Excel, and if you go over to the Developer tab, you're going to see a couple of different sections. First of all, we have XML, then we have Controls, then we have Add-ins, and lastly we have Code. And Code is where we're going to be working with macros first. So up at the top of the Code options, you see Record Macro, and if I click on that, there's going to be a little pop-up box. First thing it's going to ask for is your name, and I'm going to type in just text macro name. And under that, you'll see shortcut key, which is Control plus a blank space. If you put a letter or a number into that space and you press Control and then that, it would be a shortcut that would call up this macro. The store macro asks where you want this macro to be contained. I'm just going to click this workbook. And lastly, you have descriptions where you can type in what it does in case you forget or somebody else is trying to figure it out. When I click OK, I'm going to get an error because it wants me to not have any spaces or characters that aren't allowed in my macro name. And I also need to make sure it starts with a letter or an underscore. The reason is because Excel is going to refer to this macro, and when it calls up that name can't have spaces or it will, I guess, confuse Excel is the best way of thinking about it. So I remove the spaces, I click OK. And now if you look up at the top under the code section, where it had say start recording macro, it now says stop recording. So whenever I'm done doing the steps that I need to do, all I need to do is press stop recording, and that macro will be saved and stored just as I performed it. So now that we've learned how to make a basic macro, we're going to talk about command buttons. Because once you've made this macro, you need to be able to call forth this macro to be used when you need it. And one way to do that is with a command button. So a command button is an object that you insert into your Excel spreadsheet that is linked to a macro you created. Basically, clicking this one button will automatically summon this macro and execute it for you. So in order to insert a command button, all we have to do is go to the Developer tab, click Insert, and then there's two options. And for us, for our needs, we're going to use ActiveX controls, which basically has a little bit of the behind-the-scenes programming formatted for what we're going to be normally doing. It just kind of removes a little bit of the headache, make things easier on you. And then once you've gone to ActiveX controls, you'll click Command button, and it'll give you the option to drag to create one within your spreadsheet. So here I'm in the Developer tab. I'm going to go up here to the Insert option, and you see Form Controls first, but I'm not going to do anything with that. And then below that, you'll see ActiveX controls. And the very first option that we have is the Command button. So I click on that, and then I have this little cursor that if I click and drag and hold, will create a command button for me. So once you've created your command button, the next step is to assign a macro to it, because right now, if we clicked on that command button that we just created, Excel would not know what to do with it. So our next step is to tie a macro to that button. So every time you click it, Excel instantly knows what to do. To do this, you're going to right-click on the command button while in design mode, which I'll show you in a second, and you're going to click View Code. Now, as I mentioned earlier, if you want, you can type your code in from scratch, which isn't hard to do. You just need to know the right terminology. Or if you just recorded a macro, what you can do is you can view the macro's code that you've created and just copy and paste it from the macro itself into the button. And after you've added the code, all you have to do is close the editor. It'll automatically be saved, and then take the spreadsheet out of design mode, and you can test your macro to make sure it worked. So I've got my command button. Now I'm going to do is I'm going to come up here, and I've got design mode selected. You can tell it's selected because it is gray. If I click it again, it's the same color as the rest of the toolbar, which means it's turned off. Click it again, it turns gray, it's turned on. Now when I click the command button, I can right-click it, and I can click View Code. Now right now this is blank, but you see there's a top line and a bottom line. These are basically the bread of the sandwich. The content of the button is going to go in between, and those two things are always going to start and end it. That lets Excel know that this is where it begins, this is where it ends, and everything in between is what you need to focus on. So right now I'm just going to type message box. I'm going to explain that more in a little bit. Right now this is just an example. But once I've done that, you want to make sure that when you save your workbook, when I go to save it, it says that it's not a macro-enabled workbook. It's macro-free. So you want to make sure you're always working in a macro-enabled workbook. It's a simple type of file. When you go to save as, you can drop down and select. Uh, since I made this macro enabled, now when I click it, the macros work no problem. All right, so another way we could do macros instead of a command button, if you don't want to deal with that, is you can just add it to the toolbar. So by adding it to the toolbar, it will always be in a static position, and all you have to do is move your mouse to that position, click it, and it will do the rest. So in order to do this, we have to, like earlier when we added the developer tab, instead of clicking on the ribbon, we want to click on the quick access toolbar itself and customize it. Once we go to customize it, we get to choose the commands that we want to have available on the quick access toolbar and select macros. As a quick aside, you don't have to just put macros there. I'm going to show you in a little bit some of the other options, but this is a great way to kind of save yourself time if you know that there's certain things you're always going to need to access in Excel and you don't want to keep jumping back and forth between tabs. But for right now, we're going to focus on the macros. So you find the macro you want, you click Add It, and then if you want, you can modify the icon that appears on your quick access toolbar. So say you have a lot of macros added in there and you want to make sure that you can quickly and easily tell what's what. You have lots of different icon options, so you can assign what to what, and then instantly know, oh, the smiley face is for this macro, or the exclamation mark is for that macro. Click it and move on with your life. Once you've got your macro just the way you want it in the quick access toolbar, you click OK, and there it is. It's done. You can move forward. Like I mentioned earlier, you want to make sure that you have your workbook as a macro-enabled workbook. If you don't, then what's going to happen is it's not going to work outside of it. But if you click Save to store a macro in a hidden workbook, basically what's going to happen is that macro will be available moving forward in every single worksheet you open. I hope that's clear. If not, as we move forward, it should become a little bit more apparent. So first, a quick point of clarification. When I move my mouse up to the quick access toolbar, you'll see a little drop-down option. Now, if you click on this, you're going to see a lot of different things that you can add to your quick access toolbar, which is useful but not what we're talking about. If you right-click it, then you get to see the customized quick access toolbar option. So we come over here, and I'm going to click the popular commands drop-down. As you can see here, all those things I mentioned earlier, such as sum, save, convert into an email, things like that, they're all right there. But I'm going to go and I'm going to switch it over to macros. And you see the test macro name from earlier. I'm going to select that and I'm going to click Add. That's going to move it into my quick access toolbar. If I click the modify option while that macro is highlighted, all of those icons I mentioned earlier become available to you. I'm going to click the smiley face because, why not? And then I'm going to click OK. After that, it's going to automatically save once you click OK, and now at the top of the screen under my quick access toolbar, there's a little smiley face for my macro. So, last one of the three main ways you can deal with macros instead of a command button or a quick access toolbar is if you don't want anything to be changed about your Excel spreadsheet or the layout of Excel, you can just run a macro without a command button. This is a little bit more work intensive, but like I said, it keeps things a little bit less, I don't want to say cluttered, but it keeps some things a little bit more minimalistic if you want to think about it that way. So to do that, the first step is you open the Visual Basic Editor. You're going to click Insert, and you're going to select a module, and then you're going to take those lines from your macro that we mentioned earlier with the command button, and you're going to insert them. Then from the Developer tab, you can click Macros, select your module, and click Run, and it will run it for you from there. So before we get too much farther into macros, it's important to understand the difference between an absolute and a relative macro and when you want to use each one. By default, Excel is always going to record macros in absolute mode. This means that if you have, say, cell A1 selected when you start recording your macro, and you do work with A1, it is always going to, when you run that macro, do it in cell A1. Relative mode is if you, say, record it in A1, but then before you run the macro, you select cell C2. Then when you run it, it's going to use C2 as the focal point or the basis. The way it was recorded around A1 is now the way it is treated with C2. So this way you could kind of make it a little bit more flexible if you wanted to use it on this sheet or in this workbook in different places. Absolute mode is good because sometimes you want to make sure that it's always these exact cells, so you always get the correct returns of information, for example. But the quick and easy way to do this is under the Developer tab, there's just an option you can select, just like Design Mode, which we discussed earlier. You can click Relative References, and if you do that, it'll become grayed, and you know that that's currently enabled. So to see it in action, we're going to come over here, and like I said, right there, use relative references. I click it, it's grayed out. Now I know, just like design mode, that it's active. If I click it again, it's going to get turned off. But that's all you got to do to keep using your macro recording, but make sure it's relative. All right, now we're going to get into something that's a little bit more advanced, but like I said, if you're used to Excel formulas, then it's not something that's going to be new to you, and that is if-then. You might know it as an if-then formula. Here it's going to be an if-then statement. And there's really no difference between it except for, like I said, the punctuation that goes around it. For these, after the if or the then, you're going to do a space, whereas for Excel formulas, you'd usually follow that up with an equal sign or an open parentheses to get things the way you needed them. So before we get too far into these, I'm just going to go through the basic ones and explain what everything means. Because these are basic rules within the Excel Visual Basic formulas, and knowing what's what makes things a lot easier moving forward. So obviously with if-thens, we got to start out with if and then. So if is a condition that must be met. For example, if 1 is greater than 2, or no, that makes no sense. If 1 is equal to cell A1, I guess is a better way of putting it. That is the condition that must be met, and if it's not met, then we don't move forward with the next step. And speaking of the next step, that's where the then comes in. If 1 equals A1, then, and then we would follow it up with the next step, which is maybe color this cell blue or change cell B1 to yes. Now, sometimes we need things to be a little bit more complex, so that's where we would work in something like and or. So and is an additional condition that must be met after the if condition. And when I say must be met, it must be met. So A1 equals 1 and is red. So we will not move on to the then step if one of those things is not true. If A1 is a red cell but it equals 2, then we don't move forward. But another way you could do it is with an or statement instead. So if A1 is red or equals 1. So that way, if one of those two conditions is met, then we can move forward. And see, just as I'm saying all this, there seems to be a good amount of me using these words just to explain it. So if this happens, then that happens. So translating the way you'd normally say something, rationally from start to finish, or think about something into the Visual Basic language isn't a stretch at all because it's something you already do basically subconsciously on a day-to-day basis. So for these last two, we have else, which is just kind of the opposite, or the alternative, I guess is the better way of putting it, to then. So if this, then that. If this is not true, else. So if A1 equals 1, then we color the cell red. Else, which basically means instead of that, you would do the cell blue, for example. So that kind of gives you another condition. So if this isn't met, then we can assume that this isn't true, so then we can do that instead. But we can't have then, because then is already used for the first condition being met. So lastly, we get to not, which is a negative modifier to if, and or statements. So if not A1 equals 1, then we do this thing. So sometimes that can make things a little bit easier. It can sometimes make things a little bit clearer, but these are the 6 basic tools that we use when we're writing out our statements in Visual Basic. So here I have just a couple of different examples. It's easier than showing you the videos because the video version of this would just me showing you the lines of these codes that I'm showing you and then clicking the command button to show you the result. But first, we should walk through these so we understand. So I've already gone ahead and kept the basic 6 key phrases blue just so they stand out. And we're just going to go through these 3 lines and kind of explain it. So if a score, which is just going to be a variable that we use kind of like an extra y, because this gets a little bit more complicated if I'm typing in all of these cell numbers like A1 or A2. So if score is greater than or equal to 60 and score 2 is greater than 1, then the result that we would spit out would be pass. It's in quotation marks because it's text. Else, which means if the first condition, score 1, is greater than or equal to 60 and score 2 is greater than 1, is not met, then the result that we would spit out is the word fail. So then for the second one, like I said, we have the and, which is when both conditions must be met. For the second one, we've just replaced that with or. So if the score is greater than or equal to 60 or score 2 is greater than 1, then we can say that it's a pass. But if neither of those conditions are met, else, result is fail. And then for our last one, we've added a not to the and. So for the first line, both of those conditions have to be met. For this last line, if score is greater than or equal to 60 and not score 2 is equal to 1, which basically means as long as score 2 equals 1, we cannot say that both conditions are met. But it's easier to sometimes type that than type out score 2 does not equal 1 with the different symbols. This is all you have to do is just type the word not, and it makes it the exact opposite of whatever you typed out, which is sometimes quicker and easier. So if score is greater than or equal to 60 and not score 2 is equal to 1, then they pass. But if score is not greater than or equal to 60 or score 2 equals 1, then the result is fail. So the reason I kind of walked you guys through those ones first is because now we're going to get into something that gets a little bit more complex. But as long as we understand the words that are behind it, the rest will follow pretty easily. So we just went over a bunch of if-then statements, right? But sometimes you don't want to type out all of these if-then statements to cover all of these different instances, because then you get a whole bunch of conditions that need to be met, which not only can make it a little bit harder to keep clear in your head, but it can also be a little bit harder to keep clear in the Visual Basic write-up that you do as well. So some alternative that we have is the select case functions. And for these, it's basically a way to put all of these different little conditions within one bigger function. And it will kind of consult all of these rules you've put in place, figure out which one applies, and then go from there. So before we get into the coding of that, the first thing we want to talk about is variables. So variables can be different types of things. For this one, I have integer and string. Integer is just a number, and string is just a string of text. And when you declare these variables, you have to say what they are, because that way Excel and Visual Basic know how to handle them. If you tried to add together 2 strings of text, it's going to give you basically a longer string of text, like a first name and a last name together becomes a full name. But if you try to add together 2 integers, you're going to get a larger, or sometimes, if you're using negative numbers, a smaller integer. So having Excel understand what the variable is a great way of making sure that your macros turn out exactly how you need them. And if you look here under the declare two variables. I have score and result. And for the purpose of this, I'm trying to keep things color-coded. So score is always going to be a kind of green color and result is always going to be purple. So you can see where these variables that I'm creating are being referenced. So the very first line, DIM space. DIM is basically the shorthand for dimension, which doesn't really matter why it's called that. But basically, all you have to do is type that word, dim space, and then from there you can declare as many variables as you want in a row. All you have to do is use a comma to separate. And when you type these out, after you type in as and you press space, you're going to get a drop-down option in Excel Visual Basic Editor that gives you all of the options. If you know what you want to type in, then you can just type it in. But if you want to kind of shop around and see what works best for the situation, you totally can do that. So for this, I have dim score as integer. Score is a word that I made up. I could type in a random string of letters. I could type in score without the O. I could just type in the letter S. I could use capitalization if I wanted to. It doesn't matter. What comes after dim and before the as is whatever you want it to say, because you're the one putting this macro together, so it's whatever works best for you. So dim score as integer means that the variable I've created, score, is being declared as an integer. Comma separates that. Then the next variable, result, is being declared as a string. So once we got through that, we can start taking these variables and just like any cell with an Excel formula like A1 or B2, we start plugging these in to the formula we're putting together to make something happen. So the first line under that is going to be where we initialize the variable score with the value of cell A1. And by that basically means I'm going to tie the variable I've created, score as an integer, to a specific integer. So I'm going to say the number that's in A1 is going to be the solution to score. Score equals this number while we run this macro. And then after that, we're going to go into the select case structure. Now, the select case structure, like I said, is a way for you to lay out lots of different conditions without having to type out a lot of if-then statements. So the select case that I have here is score. So I type in the word select case and then I put in my variable. And what it's going to do is it is going to reference that variable, score, which I have defined as the value of A1. And then it's going to compare it to all of these different little cases that I've put down there. So case is greater than or equal to 80. The result, which I've already defined as a string, is going to equal very good. The case is greater than or equal to 70, then the result is going to be good, greater than or equal to 60, sufficient, and then case else is basically the catch-all of everything that isn't in one of my other conditions. And for that one, it is insufficient. Now, if you notice, it says there greater than or equal to 80, greater than or equal to 70. So we know that sometimes like the very good is also greater than or equal to 70. But when you select case structure, it's going to find the one that best fits. So for this one, it knows if you're at 81, that 80 greater than or equal to 80 is the one to go with. And if you're between 70 and 80, then the good is going to be the one you want to go with. So you don't have to worry about adding in all of these extra if it's greater than or equal to 80 and it's not less than 80, then very good. That way it kind of keeps it a little bit easier for you to keep track of. And then after I've set out all of my cases, I'm going to put end select. So the select case is the start of it. This is like another little sandwich, right? And the select case and the variable is the start of the bread, and then end select is the end of the bread. This is the bottom bit of the sandwich. And then the last line we're going to add in there is going to be what we want to spit out. So we already know that the result is a string, and we've told it what that string should be depending on what the score is, but we need to tell it where to put that string once we've run the macro. So range B1 is the defined cell it wants to go in, and then we're going to set it dot value, which is the value of the cell, equals the variable result, which was defined above. So enough talking about it. We kind of had to go through it here because I want it to be as big and color coordinated and clear as possible. Now let's see it in action. So I've got a bunch of random numbers, and I am going to come up here and I'm going to show you what happens if I run the macro. So I run it, grading test is what I have, and if I click edit, you're going to see that I've set the range to A1 and the spit out range for the result is B1. Now the problem with this is it's only going to reference the cell in A1. So I've got cells A1 through 10 all with numbers here, right? But that's only going to give me the result for the first one, A1. And we're going to come up with some ways to deal with this later, but for right now I'm just going to show you what happens when I run this macro in terms of A1. So now that we've kind of seen all of the sandwich structure I was talking about earlier, and you can see the code in Visual Basic, if I change the A1 to A5 and I change the range to B5 and I click play, it's going to spit it out for A5 and B5. So very good. Now I come up here again, and if I click edit and I change it back to A1 and B1, and I go to test it by clicking that play button, it's going to spit out there as good. Now later what we're going to do is we're going to define some ranges, and that would help you use your macro for a lot of different things. But here the problem is if I use relative references and I try and run this macro, it's not going to work for A2 because I didn't record the macro with relative references. So it's still going to try and reference the cells that I wrote down in the code itself. All right, now another select case we're going to use is the tax rate functions. And this one's pretty useful to accounting. Once again, we're going to declare two variables. We have income and we have tax. But the thing is, for these, we're going to call these double variables because these variables are going to reference multiple things. And I'm going to explain that a little bit more on the next slide. But first, we want to initialize the variable income with the value of cell A2, and we're going to round it. So once again, you get back to those Excel formulas where you just have to know the keyword of what you need to do, such as sum or concatenate, and you just reference that in the formula you type out. So income is going to equal the rounded value of A2. And then we're going to place the rounded value into the cell A2 again. So once we've rounded this to whatever we need it to be rounded to, we're going to basically update the cell A2 with this new value that we've created. We move on to our next page where we have another select case. And this is once again going to be with the variable income. And as you can see here, we've got different cases for the amount of money. So greater than or equal to $180,001. If that happens, then the variable tax is going to equal $55,850 plus 45 cents or 45% times the value of income minus 180,000. And then, we have all these different cases for each tax bracket, basically with each tax rate. But as you can see below the example, if you had $37,000, tax is going to equal, and this is for the third case, tax is going to equal $4,350 plus basically 30% of 37,000 minus 35,000. And that's going to give you 4,350 plus 600 or $4,950 total you have to pay. And then you get under that, we say we write the value of the variable tax to cell B2. And that is going to basically be range is the area that we're dealing with. We're going to define it as B2 the cell. Period value is the value of the cell, which is what we're going to be modifying. And then we're going to set it equal to the value of tax, which was defined in the select case above. Now, the reason I said that these were double variables is because if you see here, all of these are being referenced multiple times. So select case income has income within it, and you have tax within, and then you have tax in the range, and these two variables are relying on each other. You can't have the result without income and tax both working together. So you could do these as integers, but double basically tells Excel that these two are connected, and it will treat them as something that you can't do tax without having income, or you can't do income without having tax. And that kind of keeps you clear, keeps it easy, a little easier to maintain. So once again, we're going to do this in action. I've got two cells, taxable income and then the tax on income. And I don't know what tax on income is, but I do know what my taxable income needs to be. So if I come over here and I type in a number, say for example, $200,000. I'm going to have that formatted to dollars. I'm going to come over here to my developer tab, pull up my macros. I'm going to do my taxes test. When I run it, it's going to have calculated out that I need to pay $64,850. Now, if I put in a new taxable income, it's not going to automatically update. I have to go back to the macros menu, select the macro and run it again, but then I will get a revised tax on income. And I'm just going to try a couple more just to make sure that regardless of the tax bracket, we're still getting the results we need. But once you've got it tested and you know that it's working the way you want it to work, that macro is going to stay just the way it is. So you can always call it up. And if you need to modify it, you can do that from the macros menu. All right, so you saw me using it a little bit earlier. This one's a little bit more straightforward than the select case if-then functions we were just working with. But we can build off of this into some pretty useful stuff. So let's talk message boxes. It's basically a dialog box that's going to pop up whenever you click the command button. So here's some examples below: message box, space, open quotation marks, and then your message here. So the first one is pretty straightforward. It's just going to say your message here when you do it. The second one's a little bit more complicated because we're going to use that value function again. So this message box says cell A1 says, close quotation marks. So that's all going to be text that's displayed. And then it's going to say and the range A1 dot value. So it's going to finish that off with the value of whatever is in A1. And then the last one says this message is and VB is a shorthand for Visual Basic, but it's basically a Visual Basic command. So and VB new line and 2 lines long. So when you're doing an Excel formula and you want to make some sort of text string, you'd use the and to connect the two different bits of text that you're stringing together, or the value of the cell that's in between. This is the exact same thing, only to make it a little bit less muddled together, you can put spaces in between these ands to kind of break it up a little bit, and that doesn't actually confuse Excel or keep it from working. So for the last one, it's going to be a 2-line output. But for the sake of time, we're just going to see the first one here. So I'm going to insert a command button real quick. And I'm going to right-click on it because I'm in design mode. If I try clicking on it normally right now, nothing will happen. And if I right-click and I click Edit, I can change the name of my command button. So I'm going to click me is what I'm going to put in there. If you right-click on it again, another thing you can do is you can click the Properties option, which lets you see every aspect of your command button. You could do things like change the color or the font. So for example, I'm going to make it blue here, but that's a little bit hard to read. So we'll say I'll just make it a dark gray. So once you've done all of the tweaking you need to make your command button exactly how you want it, you can come back in here and you can click View Code. And as we discussed earlier, there's the sandwich with the code in between. I just typed message box, quotation marks, you did it, but let's try something new. Message box, and I'm going to type in, that was easy. Exclamation mark, close quotations. So now I come back out of here and I get out of design mode and I click on the button, and there's your message box saying that was easy. So we learned that message boxes are something you can quickly and easily type in and it will return a little box for you with a message in it. But that's pretty simplistic. So if we wanted to get a little bit more complex with it, we could use a message box function, which can actually return a result, as you'll see in a minute. But basically, the best way of thinking about that is a message box normally is just a statement, but a message box function could be a question with an answer. And to kind of make that a little bit more obvious, we're going to actually make our variable for this message box function called answer. So we're going to declare a variable called answer of the type integer, so dim answer as integer, and then we're going to try and define answer, the variable, as a input from the user. So the message box function, when using parentheses, has 3 arguments. And once again, I'm going to use some color coding to kind of keep things a little bit easier to understand. So first one is blue. The first part is a message in the message box. So if you look at the line below, the message I'm going to have is, are you sure you want to empty the sheet? All in quotation marks. Then I'm going to have a comma to separate that. And the second part, this is the purple one, is to specify which buttons and icons you want to appear in the message box. This is something you're going to have to do a little bit of research on yourself because there's a lot of options, but the ones I use are pretty straightforward. VB yes no means I want yes no buttons, and VB question means I want a question mark icon to be displayed. Once again, we're going to separate it with a comma, but as you can see between that I've got a plus to kind of let Visual Basic know where one stops and the other one starts. And then the third part, which is in green, is what is going to be displayed in the title bar of the message box. And this can be left blank and it will just default to Microsoft Excel. But for this one, I've put quotation marks empty sheet because that's the unofficial name of the function we're going to be performing today. So if you want to, if you're trying to follow along or if you're going to do this later on your own, if you move your cursor over the VB yes no in the Visual Basic editor and you press F1, it's going to open a internet browser page with an index of other buttons and icons that you can use. This is the same for other VB functions inside of Excel. So later we're going to be talking about color a little bit. You can do that with VB color. Anything with the VB in front of it, if you want, just press F1 and it will give you some more options to work with. So for the second half of the code of this message box function, once we're going to use a little color coding, yes is going to be for the yes button in green and no is going to be for the no button in red. So if, here we go with those if then statements again, if the variable answer is equal to VB yes, as in somebody clicks the yes button, then cells period clear contents. So you don't have to define any of these as variables. Excel's smart enough, it's going to know what you're talking about. So cells basically means all the cells, and cleared contents means you got to clear those contents. Else is the if they didn't click VB yes, if they clicked no. And for this one, we really don't even need to code anything. There's actually an apostrophe right there, and if you put an apostrophe in your code, it's going to turn the line green, which basically means that Visual Basic is going to ignore the code that you just put in. So you don't even need to tell it to do nothing. You could just leave it blank and it would do nothing. But I put that there just so you can kind of see what happens when the no button's pressed, get a little bit of like a visualization, if you will. And then under that, end if. If is the start of the function, end if means we're done with this and we're going to move on. So let's see it in action. As you can see, I've just filled some of the cells with some junk, and I'm going to come over to my macros. As you can see, the macro that we're going to be using is not there because it's not recorded as a macro or a module. It's recorded as an ActiveX control of this command button that we have. But all of the coding within it is done the same as a macro would be. So we come up here, you can see the code. It's under command button 1. If we click general, nothing's under general right now. If you see the do nothing is green because it's going to be ignored, but other than that, everything is in there just as it was on the Excel PowerPoint slide. So we come back over here, we get out of design mode. Now I'm going to click me. Empty sheet is the title, question mark icon, and it says, are you sure you want to empty the sheet? I'm going to first of all click no just to demonstrate what happens. As we already know, it's going to do nothing, but just want to prove the point that it's going to do nothing. Nothing happens. So now we come over here again, we click the button. This time, keep an eye on that. We click yes, and it cleans all of the cells for us. So, building off of this once again, we're going to go from message boxes to input boxes. So the message box just had those buttons, right? Yes or no, or there's those other options that you could look up by pressing F1. An input box lets you type things in. It basically gives you an empty line of text that you can fill however you need to, and then Excel will do something with that based on the coding of your macro. So we're going to start out by declaring the variable myValue of type variant. And the reason we're going to use variant here is because you can't trust people to do what you expect them to do or what you want them to do all of the time. So it could be that they're going to type in a string of text, such as a name. It could be that they're going to type in a number, such as 1, 2, 3. They could just type in a bunch of random symbols on the keyboard. We don't know. So to kind of hedge our bets, cover our bases, we're going to name the variant myValue. Once we've declared that, we're going to say that myValue is equal to the input box, and then the code for what's going to show up is just going to say give me some input. We're going to write the value of myValue to cell A1, which basically means we're going to take whatever they type in to the input that we give them, and we're going to spit it out into cell A1. And that's it. It's a little bit more straightforward than the message box coding from earlier. If we come up here to the click me button and I click on it, there you go. There's your input. Give me some input. First of all, you see you've got the text option below. I'm going to click cancel just to show you what happens when you click cancel, but this is automatically highlighted. So you don't even have to click on it. You can just start typing. And once you're done typing what you want to type, click OK. And now that has been put into cell A1. Now, this is not something that's going to have a video tied to it. It's just kind of some good stuff to understand, just kind of like one of those Russian nesting dolls. The way you type out your coding in Visual Basic should follow a kind of logical order. An object can contain another object, and that object can contain another object, and we call this object hierarchy. And there is a certain object hierarchy that must be followed when you're typing things out in Excel, basically because it's going to scan the object, right, in the way you perform the code. And so you want to start with the biggest object and work your way down so that it doesn't get confused about which worksheet or which spreadsheet you're talking about or which workbook. It always knows exactly where you're going to be coming from and where you're going to. So the mother of all objects is Excel itself. It's the number one. It's the application project, or object, I'm sorry, and that contains every other object. So for our example, once again, we're using some color coding. We've got workbooks in blue, worksheets in purple, and range in green. So Excel is an application. It is always going to be the same application. Word would be another application, but for our purposes, we're only dealing with Excel. And then a workbook is going to be the Excel file that you open. So it could be fiscal reports Q1 2017. It could be family reunion budget, but it's the Excel spreadsheet that you're going to open. And then within that, you've got your worksheets, which are the different tabs. So sheet 1, sheet 2, sheet 3, or accounting departments, inventory department, sales department. They have names, sometimes they don't, but they're the different tabs in the Excel. And finally, range is the cells themselves. It could be one cell, it could be multiple cells, it could be an entire row or column or multiple rows or columns, but it's just a defined area within a worksheet. So we've got two lines of code, and they both mean the same thing. But shorthand, we have range, A1, cell A1, value equals the string hello. But if we're going to expand on that, application, which means Excel, but it's just we're going to say application because it's referring to the application that's currently open. Application.workbooks and then we open a parentheses, create a macro is the name of the workbook, right? Or the name of the file, I guess is another way of thinking about it. Close parentheses, worksheets, uh, worksheets 1. In the parentheses, you see the 1 there. That means that if there's multiple worksheets, it's going to be for the first worksheet. So for the workbook, we had to use the name of the file, which was in the quotation marks. For the worksheets, we use the number of the worksheet, so 1 or 2 or 3. Or if you have the name of the worksheet, you can put that in there as well. And then lastly, we have the range, which in this case is just cell A1. And then after that, we've got the value. So you never have to type it like that, but if you ever get into some of the more advanced Excel VBA writing, you want to make sure they're always kind of thinking with that Russian nesting doll mentality to keep things clear for you and for Excel itself. So, as I mentioned earlier, you can use a couple of different things to refer to things. So for the worksheets, for example, I use sales for this one, the worksheet name. Purple index number, that's the number 1. And then we can also use the code name. So instead of typing worksheets, parentheses, quotation mark sales, or parentheses 1, we could just type in sheet 1. So it's not too rigid. You can be flexible with it as long as you know in your head what a worksheet is and which worksheet you want to refer to. You have a couple of different options of how you want to do that. All right, so now that we've learned a little bit more about the order of operations, let's create a case-specific calculator. And to basically explain that a little bit, when I say case-specific, basically we want to calculate things based on a condition that we set up. Like we had the select case earlier, we're going to have a case-specific calculator here. And for this example, we're going to have a group of employees who have monthly sales totals, and we want to find out the sum of these totals per employee. So we don't want the sales totals by month, we don't want them total, we want, if for example we have a guy named Bob, we want all of the sales that Bob has made totaled up for us, and that's it. So first thing we're going to do is we're going to declare 3 variables and 1 worksheet object. So the first variable is going to be a string variable, string of letters called employee. That's going to be the employee name, obviously. We're going to have a variable of the integer type that's going to be total, which is, there you go, it's going to be the total. That's going to be our output variable, basically. We're going to have a worksheet object we call sheet, which is basically going to define the area that we're searching for these employee sales totals. And lastly, we're going to have a variable of type integer called I. And I we're going to get to in a minute, but we're not on that slide just yet. So let's go ahead. We see the declarations below. They're still color-coded, so hopefully all of that is clear. Under that, we have the variable total with value 0. So we want to start out total equal to 0 because if it's equal to anything else, that could set off our final count by however much total initially equals. Plus, if we're going to run this multiple times with multiple different people, we want to make sure that doesn't carry over the total from one employee to another, because that would make that second employee look pretty good by comparison, but it could also keep your numbers off, which nobody ever really wants to happen. So total equals 0. And then we're going to create our input box function. So employee is the variable. It's going to equal the input box, enter employee name, case sensitive. Now all of this, since it's in quotation marks, is going to show up just like that. And just like it says in there, this is case sensitive. You don't always have to necessarily keep that note in there, but that could be what keeps it from working properly if people don't know that it's case sensitive. We want to have a program that can still be used if sheets are added in the future. Therefore, we're going to use the following code line for each sheet. Sheet is a variable in worksheets. And that's basically kind of like it's not like an if then or anything like that. The for is basically saying for each one of these sheets, we're going to do what's after it, which is what we're going to get to right now. So for each sheet within these worksheets, we're going to go through all of these lines that you see before you. So we're going to start a for next loop. We're going to get into loops more later. This isn't a pretty hard to keep up with loop, but basically it's going to do the job for one row and then it's going to keep moving until it's gotten through all of them. So this is where I comes into play because I is basically the interval. It's the step. So if the first row in our spreadsheet is the column headers, the month, the employee, the sales totals, then that means that we want to start our calculator with the second row. So we're going to say for I equals 2 to 13, and that is going to be rows 2 through rows 13, for example. I think in the actual video itself, it's going to be a little bit longer, maybe 19 rows, 20 rows, but basically this is going to be the steps that you're going to take to give it like the range. So if the employee entered name matches with the employee name in column B, Excel is going to add the sales number to the variable total. So to make that happen, we've got if sheet period cells. So if the cells in the sheet, and then I is going to be the row. It's like an XY coordinates kind of thing, but I is a variable, so it's always going to update those coordinates based on whatever step of the loop we're in. 2 means column 2. So it could be I equals 2, so row 2, column 2, or I equals 13, so row 13, column 2. Period value. So if the sheet cells in that row and that column that are in those parentheses, value is equal to the employee variable that was defined in the input box. Then the total is going to equal the total which we currently have, which is 0, plus the value of that sheet cells the same row but third column. So after that, we're going to do the next I, which is just going to be the next row until we've gotten through all of them. And then if we want to do more sheets, we do the next sheet after we got through those 2 to 13. This is useful if we want to do, say, multiple months, and these months are separated over different tabs in the workbook. This way you don't have to go to each different sheet to do the exact same function, and then it keeps it all kind of a little bit more centralized for you. Finally, we're going to display the total sales of the employee using a message box. So we already know all about message boxes. Message box, total sales of, and employee variable, which is just going to be the name, and is, and the variable total. I know this is a lot. Hopefully it's clear. If not, feel free to take these sheets that I've given you, the slides, and try copy and pasting this code into the Excel Visual Basic Editor yourself. Hopefully from there you can get a better idea of how it works, kind of see it in action. And that's what we're going to do right now by seeing this in action. As you can see here over to the left-hand side, I've got a month column, an agent column, and a sales column. I've got 3 months worth of information. I've got 6 different agents per month, and then I've got their sales totals for each month. And just so you can see, for fact-checking purposes, I've already gone ahead and totaled up the sales of each employee. So first thing I'm going to do when I click total sales, as you can see it says case sensitive, I'm going to click cancel. It's still going to give you a result, but it's not going to give you anything because the total is 0. Now I'm going to type in Harry lowercase. It says total sales of Harry is 0 because Harry's name is capitalized. So we try it one more time with a capitalized Harry and we click OK. Total sales of Harry is 492. Checks out. Let's try another one just for example. But first, just to prove that it doesn't make a difference, I'm going to sort them by name. So it's not going by the cell itself, it's going by the name. So if I come over here and now I try Harry one more time, it's still 492. And if I wanted to try another person, like say Irma, it is going to give me hers as well. So you can use this for a lot of different things. This is just one case that I put together, but sky's the limit. If you can think of something, now you kind of have an idea of how to make it happen. So next up, aside from the message boxes, input boxes, and text to number outputs we've been dealing with, we're going to learn about some other things you can do with macros, mainly how you can modify other Excel objects such as charts using macros. So first step is we're going to create a chart object. I know I just said object twice, but that's because the name of the object is chart object. I didn't make the rules, I just got to work with them. So chart object acts as a container for a chart object. And I know that sounds a little bit weird, but basically, if you create a chart in Excel, that is a chart object, right? So if you have a chart object, this is an object that is going to deal with all of these charts that you've created so far. So basically, the characteristics of the chart itself can change at any time, but as long as it's contained within this chart object, then you will always be able to modify it and work with it. So for this, I've just named the chart object chart, but you can use any name. But I'm going to declare it the same way I would declare a variable, but instead it is an object I'm declaring. So dim chart as chart object. Now this collection of charts, the chart objects collection, contains all of the embedded charts on a single sheet. So for us, we're going to do a loop for the first sheet because there's going to be multiple charts on there, right? We're not going to do multiple sheets, we're just dealing with this one. But the way we're going to do this is we're going to set up a little quick loop. So for each chart in worksheets 1, period chart objects, next chart. So basically what we're saying is the variable is going to deal with every single chart object in the first worksheet. And we're going to keep adding to this variable by going into each different chart and adding it to the chart variable. So this chart object represents a chart in a workbook. We're going to say that the chart, which is the variable name, period, chart, which is the object, period, chart type, which is the aspect of the object we're going to be changing, equals XLPy, which is an XLPy spreadsheet chart. So kind of like with the VB things I was talking about earlier, where if you press F1 you can get some more information. Same with this. If you mouse over XLPy and press F1, you'll get a list of some of the other chart option codes that you can input. First thing we're going to do is I'm going to show you that I've taken the agents and their sales and I've condensed them into a little bit more easy to parse format. None of those months anymore, but we've got the sales with the columns, and we've got the sales with the line. If we want to click the modify charts, it turns them both into pie charts. And you might be thinking, how is this practical for me? Well, I just put modify charts. You could also do one button for turn into pie chart, one button for turn into line chart, so you can cycle through these charts. And these two charts are identical. They have the same information, but if you say have the East Coast figures and the West Coast figures, or quarter 1 versus quarter 2, this way you can quickly and easily take a large amount of information and you can cycle between charts that may be beneficial to you to display this information. So this is more of a visual one with the pie charts, but then if you wanted a bar chart or a line chart or something like that that shows it off in a different way, having one or more of these buttons in place can save you the time of having to select each one of these charts one by one and turn it into what you need it to be. All right, next up we have range objects. So as you may remember, earlier when I was doing the macro where we tried to see if a grade was very good, good, sufficient, or insufficient, the problem we were running into was the macro that we put together was only for one cell at a time. So a range object is going to let you tackle multiple cells at the same time, basically just by defining a range. So you may already be familiar with ranges from other Excel stuff you've done, but the easiest way to think about that is if you look in the example below, I have A1:C4, and that range is going to be for 12 cells, A1, A2, A3, A4, B1, 2, 3, 4, C1, 2, 3, 4. You can also do this as a range as an entire row or columns or just one single cell, but basically a range is a way to take all of the extra hand you would have to type out and shorthands it into one little thing. So for this, I'm going to declare example variable as a range object, right? And I'm going to set the example variable to equal range A1 through C4. And then lastly, I'm going to say that the value of example should equal 8. Now, if it was just for one cell, it would just change that one cell to equal 8. But since I've defined example as a range of cells, this would automatically update all of these cells with that new number. So I have up here a make it 8 button that I've put the code into. Now I'm going to come over, I'm going to move it out of the way just a little bit, and I'm going to turn off design mode. And now I'm going to click make it 8. I've got a couple of different formatting things in place just to show you that you got to be mindful of stuff like that with your ranges. But we have 12 cells, A1 through C4, that all now contain the number 8. All right, now we've talked about ranges a little bit. Let's talk about dynamic range macros. I'm sure you guys are familiar with conditional formatting. But the thing about conditional formatting is you've got the presets, and then past that you've got to do a little bit of work to set them up. If you have a dynamic range macro in place, you can basically do your own custom conditional formatting, have it saved as a macro, and run it anytime you want. And that's basically what we're going to do here. But my conditional formatting goal today is I want the maximum number in a range of numbers to be changed to have a red cell background so I know what the maximum number I'm looking at is. So to do that, we're going to declare one variable and we're going to declare two range objects. The first variable, once again, we've got a double variable because it can work with multiple things at once, is going to be the maximum variable. Then we've got two range objects, RNG for range, and cell is obviously going to deal with the cell. So we've declared all of those. And next we're going to add in a line which is going to change all of the colors of the cells on the sheet to no fill. So the reason we're going to do this is if we're going to have one of these maximum cells turned into a red background, we want to make sure that we don't have the maximum from one result mixing in with the results of another macro that we run. So it's always going to kind of wipe the slate clean if we put in this one line, which is cells period interior, which is the fill of the cell, period color index equals 0. And we're going to get a little bit more into color later, but right now 0 equals no fill is the easiest way to remember that. So we're going to initialize our range with the numbers. We use the current region property for this because we don't know the range necessarily right off the bat. So to avoid the problem we had earlier where we tried to do the grades and it was only working with one cell at a time, current region lets you work with multiple things at the same time, and you don't have to worry about that isolation problem. So we're going to set RNG variable equal to the range A1 period current region. So this is when we use an absolute macro. It's going to be absolute based off A1 and the current region that surrounds it. But you could very easily switch this to a relative macro and do something with a similar effect. Next, we're going to initialize the maximum with the maximum value of the numbers. We use the worksheet function max, which is something that you can use in a normal Excel formula to find the maximum value. So the variable maximum equals worksheet function period max, and then in parentheses we're going to say RNG. Basically, we've defined the range and we've set it equal to that variable, so now we can just reference that variable to use the range instead of having to continuously use this range every time we go forward by typing it out longhand. Next, we're going to color the maximum value, and we're going to do this with a loop. So for each cell in the range, if cell value is equal to the maximum, then the cell period interior period color index equals 22, which equals red. And as I said before, we're going to get into color a little bit more later, but for right now, just accept 22 is going to give you a red cell, and we'll move forward from there. And then the last line says next cell, and that is just going to mean go on to the next cell. Just because one cell is the maximum doesn't mean you can't have multiple cells that are the maximum, so you want to make sure you cover all your bases. So enough explaining. As you can see here, I've got 20 random numbers, but there can be only one or maybe two or three that are the maximum number. So I click color those numbers. It highlights exactly two. 94 is the maximum, and it gives me both of them And just to show you, when you run an Excel formula, sometimes things can change if you reorder the cells. But the nice thing about the macros is, here I am, I'm going to apply a filter, and I'm going to sort it by smallest to largest or largest to smallest, and the formatting stays the same. There are no problems with it. Once you do the macro, it permanently changes the properties of those cells, and you don't have to worry about any changes you make to the layout affecting the work that you've done. All right, so we talked a little bit before about changing cell colors. We can use the same concept, but just for this, to keep it a little bit fresher and more interesting, we're going to use font colors instead. So if you were to go in and record a macro where you changed the color of a font, and then you looked at the text that was recorded in the macro by the macro recorder, you'd see for red that crazy number up there, -167766961. Nobody's ever going to remember that. If you can do that, I'm very proud of you. But that's just not possible for every single color out there. So there's a couple of more easy ways you can do it. If you look in the following line of code, I just typed in VB red. Visual Basic has a bunch of default colors. It may not be a light red or a dark red, but you've got a red that you can reference at any time. The same thing can be said for VB blue, VB green, VB white. And just like with the other stuff earlier, if you mouse over it and press F1, you can see a list of the common uses, some of the shorthands for you to reference. And then another thing you can do is in the next line down, you can use RGB, which stands for red, green, blue. And this is basically a color system where you have 3 different colors, red, green, and blue, and you have minimum 0 and maximum 255, and then anything in between. So you have these 3 different numbers that are tied to these 3 different colors, and when you mix them together, they can create just about any color out there. And a lot of times if you work with the color palette in any Microsoft Office program, it's going to give you the RGB colors. So if you wanted to make a macro and you found those RGB colors, you could usually take those numbers and put them in here to make it work. And then another thing you can do is, aside from colors, you can also, with fonts, you can change the properties of the font itself, such as the font type. For this one, I just put font bold, but anything you can think about doing with the font, strike through, italics, font size, can be changed in a macro as well. All right, so last thing we're going to talk about is something I've mentioned a little bit already. We're going to talk about loops. Now, loops are something you can do when you have a function that needs to be completed, but you don't know how many times it needs to be done. So, for example, you have a whole lot of grades, and you need to mark every single one of them as very good, good, sufficient, insufficient, etc. But you don't know if it's just 5 or if it's 10 or if it's 20. What a loop is going to do is it's going to let you do the thing for one, do the function for one cell or column or row, however you deal with it, and then once you've done it, it's going to move on to the next one. And you can either do this conditionally or you can just do it for a set range, but basically it's going to make this a very hands-off approach to dealing with a large amount of functions. Instead of having to, if you're using an Excel formula, Control D, copy it to every single Excel, this is basically going to perform the function for you with a click of a button. So let's start out with the most simple loop, which is a single loop. First thing we're going to do is we're going to define the letter I as an integer. I here is obviously a variable, and we're going to say that for the variable I, it's going to equal 1 to 6. So I is going to have 6 different values, 1, then 2, then 3, then 4, then 5, then 6. And then in the indented line under that, we're going to say cells I, comma 1, period value equals 100. So what we're doing is all of the cells that are within the parameters that we're outlining, we're going to change the value to 100. Now the parentheses have basically an XY structure. So X is going to be the row and Y is going to be the column. So for the second one, the comma, after the comma it says 1. That means we're only dealing with row or column 1 here. And the I is going to be for the axis, that's going to be the rows. So since I is going to equal 1 to 6, that means we're going to be dealing with rows 1 to 6. But if you don't want to do a range, we're going to use a loop here instead of a range. That's why you've got that next. It's going to loop around. So first I is going to equal 1, and you're going to change that value to 100. Then after you do that, you're going to move on to the next I value, which is going to be 2. And then for the second row of column 1, you're going to change the value to 100, and so on and so on and so on. This is a kind of limited example just to make sure that it's a little bit easier to understand. But if you had 1,000 rows in your loop and maybe only 900 of them are populated, but you kept adding more and more as the days go on, instead of having to constantly go through and change the range or change the for I from 1 to 972 today, 975 tomorrow, you could do a range that's larger than what you're actually searching within, and it would always cover everything that you needed to cover. So the thing is, we just talked about a single loop.